Moving on to the next topic, that is two-dimensional rotation, right? Another form of the transformation. The first form we have seen in the previous video, that is 2D translation. Please make a note of it, okay? Pause the video and note down the things. Meanwhile, I will be sharing the PDF in the group as well, okay? If you can't write the things by seeing the video, you just listen to that, but please note down the things. It should be there. This concept should be there. Very, very important topic. It should be there in your notebook, okay? Straightforward question, easily you can answer it, okay? This such type of questions will be asked for 10 marks. Explain in detail about 2D transformation or 3D, which we'll be studying in the next module. Along with the equation, matrix form, you have to explain. Very simple concept. If you understand, no, easily you can score full marks here. So two-dimensional rotation is the next form of the transformation. We generate a rotation transformation of an object by specifying the rotation axis and rotation angle. Please remember, rotation axis is required for this and rotation angle, right? We generate a rotation transformation of an object by specifying a rotation axis, because whenever you speak about, since it is 2D, so x-axis rotation is possible as well as y-axis rotation is possible. In case of 3D model, recall our lab experiment number 3 and 4. We have taken 3 different axes of rotation, x, y as well as z, isn't it? So axis of rotation should be, that is must, it should be specified along with the angular displacement value, or rotation angle should be specified, okay? Go through the next points listed. A two-dimensional rotation of an object is obtained by repositioning the object along circular path in xy plane. Of course, z is not to be considered over. In this case, we are rotating the object about a rotation axis that is perpendicular to xy, okay, which is parallel to z. Parameters for two-dimensional rotation are the rotation angle theta and a position xr comma yr. Xr is the position with respect to x, as well as yr is the position with respect to y coordinate, which is called as rotation point, okay, or pivot point about which the object is to be rotated. Please try to understand these points. Go through the diagram, you will come to know, okay? Here is a point, pivot point, which is mentioned at location xr. This is xr displacement, this is yr displacement. So point, a pivot point which is mentioned at location xr comma yr, okay? The original object, let the original object be this, the triangle. Check my pointer, check the pointer, okay? This is the original model, and you are going to rotate it about an angular displacement theta along with the pivot point xr comma yr, okay? The angular displacement, whatever it is, it can be 30 degree or 60 degree, whatever, let it be in general theta. Then the final model, see, after rotation the model is brought over here. Check its orientation, orientation is changed, okay? Unlike translation, here model orientation will be changed, because in case of translation, what you do, you don't change its orientation and all. You are just displacing, you are adding the displacement value, you are placing it at some other location without changing the orientation or size. But here orientation matters, isn't it? That is what rotation is. You just add the angular displacement of, say, along with the pivot point, say xr comma, or rotation point, you say xr comma yr, okay? Go through the next point. A positive value for the angle theta defines the counterclockwise rotation, okay, about the pivot point, and negative value rotates the object in the clockwise direction, okay? Counterclockwise, that is a positive value from here to here, that is what said as counterclockwise position, and clockwise position by adding the negative value subtraction, right, from here to here. Please check the pointer and try to understand. The very simple topic it is, okay? Try to analyze the point, you will come to know. Fine. Now let us consider about the equation as well as the matrix form. Fine. go through this diagram what is given. Okay, the angular and coordinate relationship of the original and transformed point positions are shown here. Original point and transformed point angular displacement value. Let the original point be x and y. Please remember, let the original point be x and y, transformed point be x dash and y dash. So original point, consider the plane x and y, take the initial angular displacement. This is what the initial value with respect to x plane. So with respect to x plane, what is the initial value of angular displacement for the point x comma y? That is phi, isn't it? Now check the diagram, you will come to know the point from x to x comma y, this is rotated and kept at position x dash comma y dash, right? It is not a, please remember, it is not, even though it's a point, okay, you cannot directly, earlier it would be, it was a triangle, so we could see the angular displacement orientation changed clearly the in the picture, but it's a point, no, you cannot see the orientation, how orientation changed and all, but the thing is it is not a translation. Please remember, it is a rotation. You have rotated the point and kept it new position. What is the new position? X dash comma y dash. What is the angular displacement added then? Angular displacement added is actually from the previous position, the angular displacement added is theta. Check here theta from where it is considered. What was the previous value? Previously it was kept at position x comma y. From x comma y you have added the angular displacement. Let me take this, let me highlight this. Yeah, this is what the initial point is, isn't it? Hope it is visible now. I'll choose different color better. Yeah, this is what initial point is, isn't it? So you have rotated the initial point and kept at which position? At position x comma y. Check here the thing which I am highlighting, right? This angular displacement is what? From initial to final it will be theta. Okay, now check the other thing. With respect to x plane, what is the total angular displacement? See, with respect to x plane, already it has got an angular displacement of phi. What, that is what we have considered in the initial stage, right? Now the total angular displacement while computing, you have to take from x-axis. What will be the angular displacement? It will be, see here, this is phi plus theta, right? It will be theta plus phi. Please analyze, you will understand. Okay, now now go through the statement. We can express the transformed coordinates in terms of angles theta and phi as follows. How? uh, we can express the transformed coordinate in terms of angles. Okay, one is theta and other one is phi. What is phi? Phi is the initial displacement value. Okay, we have not added anything. The initial position of the point is at location x comma y, which has got an angular displacement with respect to x-axis. Say phi is the angular displacement from x comma y. Let it be p. You have moved it to p dash, that is x dash comma y dash, by adding an angular displacement. Refer above, right? uh, Pause the video and watch it again if you have any doubt. You have added angular displacement theta for that. Here I'll show. See, this is phi initially and this is what? The angular displacement theta. Earlier I have noted down using pen. No, you can go through it once again if you have any doubt. Means, so the total angular displacement for x dash, as I said earlier, what will be the total angular displacement for x dash? See, x dash is here with respect to x-axis. What is the total angular displacement? It will be, see, now I'll be highlighting, right? So this is x dash from x-axis from here to here. What is the angular displacement? This is phi plus theta. From here to here we have phi, right? And from here to here we have theta. So phi plus theta. isn't it? That is what we have mentioned. Observe. So x dash, even x dash is marked as, recall our previous discussion, the x coordinate can be identified with the help of the cosine of the angular displacement, and y coordinate can be obtained by sine of the angular displacement, because uh, x coordinate, that is horizontal line, so cos theta is nothing but horizontal line divided by that adjacent side, I mean divided by hypotenuse, whereas sine theta is the opposite side divided by hypotenuse. That is the reason why we have written the formula like this. X dash can be obtained as follows, that is r into cos of, what is r? R is the hypotenuse value, right? So r into cosine of the angular displacement, that is phi plus theta, total angular displacement I have written here, phi plus theta. So that is what x dash is, right? So r cos theta, earlier we have considered no r cos theta and r sin theta. Now instead of just writing theta, you write the total angular displacement from horizontal plane, that is theta plus phi or phi plus theta, whatever. So this will be in the form of cos of a plus b. What is cos of a plus b? Recall trigonometric function, it is cos of a plus b is cos a cos b minus sin a sin b, isn't it? So cos of theta plus phi is written as, see here, cos of theta plus 5, sorry, so r of cos of r into cos of theta plus 5, that is r, the multiplicand will be there, cos theta cos phi, that is cos phi is the first parameter, now cos phi into cos theta minus r sin phi into sin theta. Check the formula, isn't it? Then similarly y dash can be obtained as r sin phi plus theta. So r into, what is it is in the form of sine of a plus b. What is sine of a plus b? Sine of a plus b, that is sin a cos b plus cos a sin b, isn't it? Now so check here, r of sine of phi plus theta. So sin theta cos phi you have taken, anything you can take, okay, or cos phi sin theta or sin theta cos phi, whatever you take, plus r into sin phi cos theta. Cos of a plus b form, it is in the form of, okay, right. This is the second formula, two equations we got now by the time. Okay, the original coordinate of the point in polar coordinates, the original coordinate of the point x and y, how to represent x and y? What is x? See here, what is x? X is, so this is the original point, right? X comma y. What is x? How to represent x in the polar form? It can be represented as x equal to, what is the hypotenuse? Hypotenuse is r, r into x, no? So which parameter to be considered? Sin, so cos, sorry, cos parameter is to be considered. Cos of what is the angular displacement? Check. So you are talking about x. What is the angular displacement? Phi is the angular displacement. Hope it is visible, isn't it? X into r, sorry, x equal to r into cos phi, that is r cos phi. Refer the equations over here, sorry, so refer the equations over here, x equal to r cos phi, and what is y? Similarly we will get r equal to sorry, y equal to r sin phi. If you have any doubt, watch the video again, pause the video, rewind the video, okay, note down the things. How sin phi is considered? Y parameter. So y parameter is obtained by considering the which opposite side, right? Opposite side is the y axis, equivalent to y axis there. So we are getting y equal to r, that is hypotenuse, into sine of angular displacement. What is the angular displacement for the original point? It is phi. It is not equal to theta, isn't it? Now substitute these values r cos phi and r sin phi as x and y in the above equation. See, we are getting r cos phi here. Observe carefully. We are sorry. So we are getting r cos phi as well as r sin phi over here. See, r cos phi we are getting, r sin phi we are getting, right? Those things to be substituted in the even same thing is there in the equation 2 as well. So we can substitute it by x and y. We are, after substituting, we will be getting the simplified equation as x dash equal to, see the simplified equation, x dash equal to x cos theta minus y sin theta, because sin phi and cos phi we have substituted. R cos theta, r cos phi as well as r sin phi we have substituted as x and y respectively. So what we are getting after substituting that, instead of r cos phi cos theta, we are writing it as x cos theta. See where we are writing that, here, x cos theta. That x is come how, with the help of the above formula. X is nothing but r cos phi, this one, right? So we got that simplified equation. Similarly, y we have substituted, then for y dash also x sin theta plus y cos theta we are getting. So we can write the rotation equation in the matrix form. How? Earlier we have written, no? In the same way we can write the equation p dash is the new point which is equal to r into p, where r is the rotation matrix. Please try to understand. R stands for rotation. So what is rotation? You have to write the matrix in the form. It is very easy to write the matrix, this matrix. Observe the above equation, you will come to know. Hope this is visible. Sorry. So we are talking about this, right? X dash is x cos theta minus y sin theta. Observe the coefficients. X dash, so coefficient of x we have to write over here in place of r. What is the coefficient of x? That is, check, cos theta. Cos theta is written. What is the coefficient of y? It is, include the sign, okay, minus is there here, minus sin theta. So minus sin theta is the second parameter. That is, for first row represents the x dash value, second row should represent the y dash value in the same way. So y dash value, what is the coefficient of x? This is x, right? For y dash, hope it is visible. So y dash, what is the coefficient of x? Coefficient of x is sin theta. Write that over here, sin theta. And what is the coefficient of y? Coefficient of y, you check, coefficient of y we have cos theta. So coefficient of y we have cos theta, it is written over here. Fine. Okay. So rotation about the rotation of a point about the arbitrary pivot position, which is illustrated, the same diagram is illustrated over here. That pivot point is marked as xr comma yr. Rest of the things are same. Earlier it was on origin, so we have considered the origin. Refer the diagram, see the difference. Okay, we have started with the origin earlier in the previous diagram. Now what we have considered? We have considered a pivot point, say x or y r. This x or y r will be acting like origin. Okay, actually it is not a origin. From origin it will be having a displacement of r with respect to x as well as r with respect to y points. Okay, so we can write the x dash and y dash in the same, in the above formula we are substituting the value. That's it. Okay, try to understand this formula. Okay, go through the statements. This formula you should try to understand, because it is the same as that of our previous diagram, but instead of taking the points from origin, we have taken it from the displacement value, that is xr comma yr. Fine, that is all about the rotation. Let us continue our discussion in the next session. If you have any doubt, any difficulty, you ask.